This is part 2 of our video on geometric sequences. In part 1, we talked about what a geometric sequence was, and we came up with a generic formula for the explicit equation of a geometric sequence. So we're going to try applying that and doing a couple of questions. So we're going to take a look at the first one here, which says write a formula for the nth term, which means basically for any term. And then we want to determine the 15th term in the sequence 1, 5, 25, 125. So with any question, when you're dealing with sequences, you always want to start by figuring out the pattern. So I'm going to try to figure out what I did to get from 1 to 5, from 5 to 25, from 25 to 125. Now I can tell that I have multiplied by 5 to get 5, and then I have multiplied by 5 to get 25. And if you weren't sure about the 125, you can take your calculator. Actually, you can do it on any of them, and you always take the second term divided by the first. So 125 divided by 25 is 5. Now I know this isn't arithmetic, which is where we add by the same term every time, because I would have added 4 and then 20 and then 100. So since it's not the same number, I know that it's not arithmetic. So what I'm going to do is calculate first a formula for the nth term, and then I'm going to actually find the 15th term. So I am going to start by writing down the formula, which we just learned, which is Tn equals A times r to the power of n take away 1. So Tn is the term we're looking for. So in this case, it would be the 15th term. For the formula, it's just going to be Tn. A represents your first term in the sequence. So in this case, that would be a 1. R is your common ratio. That's what you're multiplying by every time. So in this case, we are multiplying by 5, so the ratio is 5. N is the number that you're looking for. So if I'm looking for the 15th term, I would put 15 in for N. If I'm doing the nth term, I'm going to leave it as an N, and that's just a 1. So I am going to list all of my values down the side. Now, sometimes I write Tn, sometimes I'll just do T. They really mean the same thing. I know the first term is 1, and I know that my common ratio, we said we were multiplying by 5. Now, I do not know what n is yet because we're doing the nth term first, and I'm not sure what Tn is because we're doing the nth term first. So I am going to just substitute what I have into the formula. So we're looking for a generic equation that works for any term. That's what the nth term one is. So Tn, we're leaving that alone, is 1 times r, which is 5, to the power of n take away 1. Now, you cannot multiply the 1 and the 5 together. You have to follow order of operations, which says you need to do exponents before you do your multiplying. So because I cannot evaluate 5 to the power of n minus 1, this is what the formula is going to look like. I cannot simplify it any further. You cannot multiply those two numbers together. So that is going to be my formula for the nth term. Now to find the 15th term, I'm actually going to take that formula, and everywhere I see an n, we're going to substitute in 15. So T15, term 15, is 1 times 5 to the power of n, 15, take away 1. Now I am going to simplify the exponent here. 15 take away 1 is 14, so it's 1 times 5 to the power of 14. Now remember, you do need to do your exponent first. So on my calculator, I'm going to do 5 to the power of 14, which is that terrible looking number. And then I'm going to take that answer, since I don't want to write it down twice, and multiply it by 1, which gives me the exact same thing. So I end up with 6,103,515,625. And that's my 15th term. Now, I have to point out I made a mistake here. Somehow along the way, my term 15, I started writing it as a 14. That's because when I did the subtraction, I got a little confused. So I apologize there. That should be a 15. Please make sure you make that correction. Okay, so we're going to try the next question. We want to determine the number of terms in the sequence with those beautifully large numbers. So first thing you want to do is see if you can figure out if it's arithmetic or geometric, what's the pattern, what's happening here. So I'm taking a look at those numbers. I see that this is 23 million. This is 7 million. And then this is 2 million. So here I'd have to subtract a very large number to get it down to 7 from 23 to 7. And then it wouldn't work out to be 2 for the next one. So I know this isn't adding and subtracting. So I'm going to try taking the second number and dividing it by the first number. So I've got 7, 9, 7, 1, 6, 1, 5. I'm dividing that by 23, 9, 1, 4, 8, 4, 5. And I found that I'm multiplying by 0.33 repeating. Now, I do not want to use a decimal that I have rounded. So what I want to do instead is figure out what that is as a fraction. If it had worked out to be exactly 0.3 or a nicer decimal, I would have used it. But because it's got all of those decimal places and I'd have to round it, I'm not going to do that. So if you're trying to find a fraction that works for this, instead of doing the second number divided by the first number, we're actually going to go the other way and do the first number divided by the second number. So 23, 914, 845 divided by 7, 971, 615, and I get a 3. This doesn't mean that I'm multiplying by 3 because clearly I'm multiplying by 0.333. What this is telling me is that I'm getting a fraction of 1 over 3 instead. So when I take the first number and divide it by the second number, it's always to get a fraction, right? And here I'm getting a fraction of 1 over 3. Now I am going to just check, right, that this works. So instead of typing in these numbers again, I'm just going to take this one and I'm going to try multiplying it by 1 divided by 3. So 7, 971, 615 times 1 divided by 3 gives me this number, so I know that that's right. So the 1/3 here is called my common ratio. I know this is geometric because we're multiplying. So I'm going to use my formula, Tn equals A times R to the power of n take away 1. And I'm going to list my T, A, R, N. Now I know that A, that first number, is that really long number. It's the 23,914,845. R is going to be 1/3. N is going to be, well, I don't know. I'm not sure how many terms there are. That's actually what it's asked me to find. It wants to know how many terms there are. So there has to be a way that I know what T is. Now, I know the first term, the second term, the third term. It also gave me the last term. So if I could figure out which term the last term was, it would tell me how many terms there were. So if this is term 10, there are 10 terms in the sequence. If this is term 50, there are 50 terms in the sequence. So what I want to do is put this in as my last term, as the final answer, and then figure out which term it was in the sequence. So I'm going to substitute in all the things I know here. So 5 is my Tn, and then 23,914,845 times 1/3. Now I am going to put the n-1 outside the bracket because I want to keep that 1/3 together. If you want to add a second set of brackets around that, that's up to you, but you don't really need them. So what I want to do is solve for n. I cannot multiply these two numbers together because it goes against order of operations. So I need to figure out some way to tackle this. So since I'm trying to solve for n, I want to try to move some things to the other side. So I'm going to start with this number out front. I can't multiply them together, so I might as well take it to the other side. And we're going to do that by dividing both sides by that number. Now, if I try that on my calculator, 5 divided by 23,914,845, I get this number. I don't know if there's further decimal places after this. I would guess that there were. So I am not comfortable with using that decimal. I would like to leave it as a fraction, and I would like to reduce it if I can. So I see that the number on the top is a 5. I see that the last digit of the bottom number is a 5, which tells me that both of these numbers are divisible by 5. So I'm going to divide 5 divided by 5, which is 1. And then I'm going to take 23,914,845 and divide that by 5 as well. So didn't make it a whole lot better, but it is a little bit smaller. So I have 478,2,969, and that equals 1/3 to the power of n minus 1. Now, to continue solving here, I notice that this is in the exponent. I cannot take the base to the other side and divide or multiply. I have to do something different because I'm trying to solve for an exponent. So in our previous unit, we learned that to solve for an exponent in an exponential equation, you need to write these both as powers of the same base. So since this is already a 1/3, I want to try to write this as a power of 1/3. So to do that, it's easier just to focus on the denominator and see if I can figure out what this is as a power of 3. So there are a couple of ways to do that. Number one, you could try trial and error on your calculator. You could start doing 3 to the power of something until you find one that works. Your other option is to use the power sheet that I gave you. Okay, now when I look at my powers of 3, I see that I've got 59,049 is the biggest number there is. So what I can do is I can take that 478,2,969 and divide it by the biggest number I've got, so 59,049. Oops. And I get 81. So this was 3 to the 10. And then 81, if I look at my sheet, is 3 to the 4. So if I add 10 and 4 together, I get 3 to the power of 14. So I'm going to try that, 3 to the power of 14, which is the number I'm looking for. So this is going to be 1/3 to the power of 14 equals 1/3 to the power of n minus 1. Now, since the bases are the same, the exponents have to be the same. So 14 is going to equal n take away 1. And then we do a little bit of grade 9 math. We add 1 to both sides to get that n equals 15. So there are 15 terms. Okay, I think that our last question is going to take a little bit longer, so we're going to do that in part 3. So I'll see you in a minute.